Welcome, students. Hey, in today's lesson, you're going to learn a really valuable tool, something that you can accomplish with inverse matrices, and that is encryption. Being able to take a password, something that needs to be private, and send it to another person, but keep the integrity of that password safe. Keep that password so that nobody else could steal it while it was en route to where it's trying to go. Okay, so I'm going to give you an example here of I'm going to create a password for myself. And I'm going to show you how we could encrypt it using a matrix called a coding matrix, but then how we could descramble it using something called a key matrix. Okay, so first off, let me come up with a password. I'm going to go with one of my all-time favorite basketball players, LeBron. That's a good 6-letter word. All right, so here is my password. I decide I want to use LeBron as my password. Maybe my login to a website, something of that nature. LeBron is my word. Now, for this lesson, I'm going to just keep a simple, I'm just going to use this simple pattern here. I'm going to assign the letter A, the number 1, the number B, I'm going to call 2, C, I'm going to call 3, etc., on down the list. So for LeBron, I'm going to turn this into numerical values. I'm going to say that it's 12. E is 5, B is 2, you get the idea, R would be 18, 15, and 14. Okay, now here's what I'm going to do. You can make these more complex with larger columns and whatnot, but to kind of keep this simple to begin with, I'm going to create what's called a password matrix. And for our lesson today, we're going to keep all of our passwords down to 2 columns. So in this case, in order to fit these 6 letters, 12, 5, 2, 18, 15, and 14, to be able to fit them all into 2 columns, I'm going to make it a 2x3 matrix here. Now, if I had to, let's say I had to type in my password and submit it to a website, I would not want somebody to steal that password while it was being transmitted to that website. So what we're going to do is we're going to scramble this password using what's called my coding matrix. Okay? I'm going to multiply this password by 4, 5, 2, and 3. This is called our coding matrix. And what this will do is this will scramble the password so that it's completely unrecognizable. If anybody were to try to steal this password, it'd be unrecognizable. Nobody would be able to make sense out of what it is. Now, here's what I'm left with. Since this is a 2x3 being multiplied by a 2x2, I can go through a few of the steps with you to help you remember how to do this. And first off, my apologies. This is not a 2x3. This is a 3x2. My mistake, but reminder how to multiply matrices. These inner dimensions mean that the multiplication is going to be possible. And then these outside dimensions tell me what size my solution is going to be. The solution is going to be 3x2. So I'm going to make a blank 3x2 matrix to keep my answer. All right, and then just a quick reminder, what I'm going to do, I'm going to circle the rows of the first matrix, group it by its rows. I'm going to circle the columns of the second matrix. And to find my top left element, I'm going to group my top row, the 12 and the 5. I'm going to group it with my left column, the 4 and the 2. And it looks like this, 12 times 4 plus 5 times 2. That is 58. Let me do one more kind of showing all my work. To get my top right answer, I would take my top row of my first, the 12 and the 5, and I would combine it with the right column of the second, the 5 and the 3. 12 times 5 is 60. 5 times 3 is 15. That adds up to 75. All right, I'm going to fill the rest of these in real quick. All right, and here is everything worked out. I got 58, 75, 44, 64, 88, 117. Now this answer that I got, this product here, is called my scrambled matrix. This, when I submit my password to a website and it's sent through the internet, this is what's actually sent. And if somebody were to steal this, they would have no idea that this means the word LeBron. There's absolutely no way somebody would be able to figure this out. The patterns are kind of too complex. And there's different ways to make it even more complex than this, but just generally, if somebody were to steal this, I can feel safe and secure knowing they still don't know my password, even if they steal this information. Okay? There's no way somebody would know that this means LeBron without having the coding matrix or the key. So let's pretend for a second that this is what I send through the internet as my password. I don't send my actual password, I send this scrambled version of my password. So now we ask the question, well, how is whoever's on the receiving end of this password, the website, whatever it may be, how are they going to decode or unscramble this password to know that it means LeBron? Well, the whole key to this is using inverse matrices. Well, whoever receives this scrambled password is going to have to know what's called the key matrix. And the key matrix is actually just the inverse. Okay, the key matrix is actually just going to be the inverse of my coding matrix. Okay, and I'm going to go ahead and find the inverse of this 4, 5, 2, 3. I will show all my steps. I'm not going to talk through every single step, but I will show my work if you need a refresher of how to find this. But here we go. Let's find the inverse right now. All right, so here is me finding the inverse of the coding matrix. Remember, I'm going to flip the 4 and the 3. Those get flipped along that diagonal. And then along this diagonal, the 2 and the 5 stay in the same position, but they turn into the opposites, -2 and -5. And I'm going to multiply all of this by 1 over the determinant. I found the determinant to be 2, so I'm going to multiply all of these numbers by 1/2. So what I get, I could leave it as a fraction or as a decimal. If I get 1/2 times 3, I'm going to go ahead and do decimal. I get 1.5. 1/2 times -5 is -2.5. 1/2 times -2 is -1. 1/2 times 4 is 2. The inverse of my coding matrix is called my key matrix. And whoever receives my scrambled password will have to have this key to figure out that it means the word LeBron. Watch exactly how this works. If I take my scrambled version of LeBron, multiply it by this key, 1.5, -2.5, -1 and 2, I guarantee you the result will be LeBron. Now remember, this is a 3x2 matrix being multiplied by a 2x2. So it is possible, and my solution is going to be another 3x2 matrix. Let's do, we'll do maybe the first step or two together, and then I'll finish it off. So my top left element, I'm going to take my top row, the 58, and the 75, and I'm going to combine it with my left column, the 1.5 and the -1. Now listen, this should add up to the letter L. Let's see if it does. Well, this ends up being 87 plus -75, just like magic. Guess what? It came out to 12. It came out to L. This is great. Let's do one more together, and then I'll just kind of finish off the rest. So to find my top right answer, I'm going to take my top row, the 58 and the 75. This time I'm going to combine it with my right column, the -2.5 and the 2. And believe it or not, when I multiply these together, I know that's written really small there, but when I multiply these together, it comes out to 5, and that's great because that means E. All right, and you can work through the rest of the steps if you'd like, but what it comes out to, this element will come out to 2. This one comes out to 18. This one comes out to 15. This one, the last one comes out to 14. Guess what? I got the word LeBron. Using the key, taking the scrambled matrix times my key, I'm able to get back to my original password. And this is how messages and passwords are encrypted so they can be sent through cyberspace and kept safe and secure. And I'm going to add my work here in case if you need it. And there's all the little steps, but look, it came out to be LeBron, which is exactly what I wanted. And a quick note right now on the kind of the importance of inverse matrices and kind of the purpose of them. So here you can see I took my password and I multiplied it by a coding matrix in order to scramble everything up. Well, in an ideal world, if you want to undo a multiplication, with normal numbers, you simply divide that number away. But unfortunately with matrices, there's no such thing as dividing a matrix. So what have we come up with instead? We've come up with an inverse matrix. An inverse matrix will always undo the multiplication that was done with an original matrix. And so this inverse matrix, when I multiply, it undoes the multiplication that was done here, and it brings me back to my original password, 12, 5, 2, 18, 15, and 14. So here I have one more for you to try on your own. Here is a scrambled matrix. I have come up with another password that I thought up in my head, and I went ahead and multiplied it by my coding matrix, and I came up with this scrambled variation. Now, there's no way you're going to guess what this means. 104, 137, 106, 144. There's no way you know what this means just looking at it. In order to unscramble this, you're going to have the key. Now, let's just use the exact same key that we used in our first example. Now, by the way, the key in the coding matrix can change all the time. In our first example, we used the same coding matrix, and we were left with the same key. And so we're going to just stick with this same key here. But realize on your assignment, it's going to be a completely different coding matrix and a completely different key. But just to stay consistent with this video, let's use this key, use matrix multiplication, see if you can unscramble my password. It's only a 4-letter word. Go ahead and hit pause on the video right now. Try to figure out what my password is. And here we go. I've set up all of my work. When I do this calculation for the matrix multiplication, I get 19, and that is the letter S. When I do this multiplication, I get 14, and that is the letter N. When I do this multiplication here, I get 15. That is the letter O. All right, I've got S and O. It's going to either be snow, snob, snot. I don't think it's that. All right, do my last calculation here. The last calculation, it comes out to a 23. I've got the password. The password was snow. Okay. Hey, with this lesson behind you, you are ready for your assignment. Best of luck for you on this assignment, and happy encrypting. Take care. Bye.